In this video, we're going to take a look at differentiating hyperbolic functions. So to begin with, let's just state the three results that we need. So the first result here is the derivative of sine x, that's going to be d by dx of sine x. Now in this case here, this behaves like the regular trig functions. If you differentiate sine x, you get cos x. If we differentiate sine x, we get cosh x. Okay, so that's our first result. So now what happens if we differentiate cosh x? So d by dx here of cosh x. Well, what I get here now isn't like the regular trig function. So if you were to differentiate cos x, you get minus sine x. But be careful here, we don't get minus sine x, we get positive sine x. Okay, so that's positive sine x. And then finally, for the last hyperbolic trig function here that we're going to differentiate, so d by dx then of fan x. Okay, now this does behave like the regular trig functions. If you differentiate tan x with respect to x, you get sec squared x. So in this case, we get sec squared x. Okay, so sec squared x there. So those are the three results that we need. What I want to show now is how we actually derive the derivative here of sine x and cosh x by using the exponential definition. What we'll do now is we'll clear the screen. And let's have a look then at showing that d by dx here of sine x is equal to cosh x. So let's start here by stating that y is equal to sine x. So y is equal to sine x here. Now we know the exponential definition for sine x. That's e to the x minus e to the minus x all over 2. Okay. If I differentiate y here with respect to x, dy by dx, what we're doing there is we're differentiating sine x with respect to x. It's going to be d by dx then of sine x. But in this case then, using the exponential definition, it's just the same as differentiating this exponential definition here. So what we're looking to show now then is the derivative here, so d by dx of sine x is equal to cosh x. Okay. So what I'm going to do here to start with is just write this as y equals sine x. Y equals sine x. Now, if we were to differentiate this here, we'd get the derivative of sine x. But before we do that, let's remember the exponential definition. Okay, so we know that sine x, we can write that as e to the x minus e to the minus x all over 2. Okay, so if I differentiate this here, we get dy by dx. So we're going to get the derivative here of sine x, so that's going to be d by dx of sine x. But in that case, now that's just the same as finding the derivative of this exponential definition here. That's d by dx of e to the x minus e to the minus x all over 2. Okay. What I'm going to do now is I'm going to differentiate this here. What I do is I split this up as two separate terms. So that's the same as e to the x over 2 minus e to the minus x over 2. And then just differentiate term by term. So if I differentiate term by term here, well, e to the x over 2, if I differentiate that with respect to x, that would just simply give me the same thing. So I'm going to get e to the x over 2. And then if I differentiate minus e to the minus x over 2, then this minus 1 here in front of the e, that's going to be multiplied by the minus 1 here from the power. So that becomes positive. I'm going to get plus e to the x, to the minus x all over 2. Okay. So what I can do now is write this over a single denominator because they have a common denominator here. I'm going to get e to the x plus e to the minus x over 2. And notice now that this here is the exponential definition for cosh x. Okay, this is equal to cosh x as required. Okay, so that's how we derive the result there for the derivative of sine x. Let's have a look now at deriving the result then for the derivative of cosh x. So let's clear the screen here. So in that case then, what we're looking to show here is d by dx of cosh x is equal to sine x. And the result here largely follows in the same way. So we're going to start by stating that y is equal to cosh x. And then we're going to state the exponential definition for cosh x. That's going to be e to the x plus e to the minus x all over 2. Okay. So what I'm going to do here now is differentiate this. I'm going to get dy by dx. So dy by dx. That's going to be the derivative then of cosh x. That's d by dx for cosh x here, which is just the same as differentiating the exponential definition here. So d by dx then of this exponential definition, so that's e to the x plus e to the minus x all over 2. Okay. So again, split this up now as 2 fractions and then differentiate term by term. In that case, if I differentiate e to the x over 2, again, that would just simply give me e to the x over 2. And then I've got e to the minus x over 2, so if I differentiate that here with respect to x, that's going to give me minus e to the minus x over 2. Like so. Okay. Now again, I can write this over a single denominator because they have a common denominator here. That's going to be e to the x minus e to the minus x all over 2. And notice here now, this is the exponential definition for sine x. This is sine x as required there. Okay. And there we have it. So that's how we derive the results there for the derivative of sine x and cosh x. So now let's take a look at a couple of practice questions for using these derivatives. Starting off with question 1 here then, we've been given that y is equal to 3 cosh 2x, and we're asked to show that the second derivative of y with respect to x is equal to 4y. So to begin with here, it makes sense to just find the first derivative. That's going to be dy by dx. So if I was to differentiate cosh x here, that would be sine x. If we're differentiating 3 cosh 2x with respect to x, then in that case here, we need to use the chain rule. We're going to do 3 times 2, which would give me 6. Then in that case, we're going to get 6 sine 2x. Okay, so 6 sine 2x. That's our first derivative. So what I need to do now is differentiate this one more time here to get the second derivative. So for the second derivative here, I'm just going to differentiate one more time then. So we're going to do the chain rule again here. So 6 times 2 would give me 12. And if I was to differentiate sine x, we'd get cosh x. I'm going to get 12 cosh 2x here. Okay, so we get 12 cosh 2x. Now we're actually asked to show here that the second derivative is equal to 4y. So in this case then, when I look at my expression here for the second derivative, what I actually want to do here is just factor a 4 out. Okay, so I can write this now as 4 lots of 3 cosh 2x. But remember, y is equal to 3 cosh 2x, so in that case then, this is equal to 4y. Okay, so that's equal to 4y as required. And that gives us the solution there to question 1. Moving on to question 2 then, we've been given that y is equal to x cubed sine 4x, and we're asked to find dy by dx. Now what you need to notice here is that we have a product of functions. So in that case, if we have a product of functions and we need to find the derivative, we need to make use of the product rule. So I'll take u here as being x cubed, and v in this case will be sine 4x. That's sine 4x. And what I need to do now is find the respective derivatives here. So u prime, that would be nice and straightforward. That's going to simply be 3x squared. And v prime here, which will be 4 cosh 4x. Okay. So now, if we're using the product rule here, let's just state that result. So dy by dx. Using the product rule then, this will be u v prime. So u v prime plus v u prime. Plus v u prime there. So putting all that together then, I have u v prime, so that's going to be x cubed here times 4 cosh 4x. That's going to be 4x cubed cosh 4x. And then we have vu prime here, so sine 4x times 3x squared. Putting those together, it's going to be 3x squared sine 4x. Okay. And there we have it. So that's our result there for dy by dx, giving us a solution to question 2. Taking a look at the very last question now, we've been asked to differentiate cosh x over 4x with respect to x. What you need to notice is we have a quotient of functions. So u here will be the numerator, which is cosh x in this case. And my v here will be the denominator, which is 4x. And what I need to do now is find the respective derivatives. So u prime here, that's going to be the derivative of cosh x with respect to x. That would give me sine x. And then v prime here would be the derivative of 4x with respect to x, which will simply give me 4. Okay. Now we're using the quotient rule here. Let's just state the result then for the quotient rule. So dy by dx, this is going to be equal to vu prime, so vu prime minus uv prime, and then we divide this by v squared. Okay, now remember, for the quotient rule, the order is important here with the numerator. So all I need to do then is put all of this together. So vu prime, so v is 4x, times that by u prime, which is sine x. So I'm going to get 4x sine x there. Okay. Then we minus uv prime. So u is cosh x, times that by 4. I'm going to get minus 4 cosh x. Okay. And then we divide this here by v squared. So if v is 4x, we divide this by 4x squared. So 4x all squared, which would give me 16x squared. Okay. We divide this by 16x squared. Now, we could technically leave this as it is here and call that the solution, but what I will do is simplify this so I can pull out a 4 here in the numerator. So I can write that as 4 lots of x sine x minus cosh x. Divide this by 16x squared. And what I can do then here is cancel a 4 in the numerator and the denominator. So that 4 there will cancel. This will now become 4. What I'm going to get then, if we do it underneath, is x sine x minus cosh x all over 4x squared. Okay. And there we have it. So that's our solution to question 3. And that brings us to the end of this video on differentiating hyperbolic functions. So in the next video, we're going to take a look at integrating hyperbolic functions.